finish off the animation blueprint here. Back to locomotion, there's one more state that we need to cover, and this will be the absolute bare minimum if you were to release a game. Spacebar, jumping, A on an Xbox controller or X on a PlayStation controller. As I alluded to before, this is going to be 3 different states, and they're down here. We're going to start with a jump, start, and then we're going to move to a jump loop. And then once we've landed on the ground, we're going to play jump end and return back to either rifle run or rifle idle. So let's drag these down here and start plugging them in. Rifle run to jump start is going to be an easy Boolean. Let's go back to the event graph. Let's drag off of B_hero and get is falling. For all intents and purposes, falling and jumping are essentially the same thing. If we fell off a ledge, it's not going to hurt us to play that jumping animation. And if we wanted to go straight into the falling animation, we can set that up later. So let's create another variable, and we could also right click and promote to variable here to create a variable just as we've done before. We'll call this is falling and plug that executable into here. I'm not too overly concerned with cleanup because we have a lot of work to do in here, and whatever I clean up now will need to be readjusted later. So we have a Boolean. Let's go back to locomotion, double click on the transition node and drag in is falling. So when we jump, we enter the falling phase, or when we fall off a ledge, and the first thing we'll play is this animation. To get from jump start to jump loop, which is an animation that just loops over and over again to simulate falling, to get over there, we're going to use another node which is unique to animation blueprints. Right click and type in the name for your jump start animation. So FPP _ rifle jump start, and you will get a whole bunch of nodes relevant to that animation. We're going to select time remaining. And with time remaining, we're going to drag off of that and check if time remaining is less than a certain value, because by checking that, we also get a Boolean. So when we are less than 0.1 seconds from the end of this animation, we will switch to the jump loop. Compile and save that. Back to locomotion. We're going to create another transition for when we go from loop to end. This one is going to be if we're not falling. So drag in is falling, holding control if you want to get the getter immediately. Type in not and plug that in there. And select all of this, hit Q if you want to neaten that up. And then back to locomotion, let's make one more transition to get back to run. And if we double click on that, this will be FPP _ rifle jump end. We'll get the time remaining on that. And if the time remaining is less than 0.1, then we will return to our running animation. But then our running animation will also determine if we return to our idle animation. So that's what the very, very, very basic version of this blueprint looks like. With that compiled and saved, let's go over to the test map, hit play, and try jumping. There it is. Jumping is working. Now, before we finish up, let's do 2 things. Let's put the gun in the hands of these arms. To do so, we're going to pop over to characters, which is a new folder that we got from doing that migration. We're going to open up Hero FPP, and we're going to open up Hero FPP Skeleton. This is what we've been working with so far. It is a skeleton with a mesh built on top. This is an asset that would be created in something like Blender or Maya, and ultimately a 3D artist or animator would have created this for you and you would have acquired it, which I'll talk about more in a later video, the relationship between animators and us programmers. If we pop over to the left here and select the skeleton tree, we can see every single joint that's inside of this skeleton. So we have a root, which is why we had to hit negative 150 down there once we got into the B_hero here, because that root has to hit the ground like that. And then if you were to use your arrow and select all of these, you would see all the different joints. All these joints are used to create the animation. We're only interested in one for the moment, and that is the right hand joint here, B_right hand. We don't need to do anything from the skeleton though. We're going to do it from our B_hero blueprint. I just wanted to show you where this was. If you're looking for a bone, you can find it here. So closing that, let's go over to B_hero and let's drag our equipped weapon on top of our skeletal mesh. So our skeletal mesh is attached to our camera and our equipped weapon is attached to our skeletal mesh. With the equipped weapon selected, go over to parent socket. This is where we will refer to whatever bone we want to attach to. In this case, B_right hand. It has to be typed in exactly, but fret not. One of the newer features since I started using Unreal is if you hit this magnifying glass here, you'll actually get a reference of all the bones attached. So if I scroll down to B_right hand and select that, I will get the correct bone to attach. But you can see my weapon's also gone haywire here. When I deleted the skeleton for this video, the weapon tried to keep its original place, and so it tried to readjust, but it's not readjusting back onto the bone. This gets really finicky because we are trying to essentially line up a weapon that was not designed for these arms into these arms, and it's not going to be 100%, but take your time, get it as close as you want, and take solace in the fact that if you were to hire an animator, you would have them molded around whatever gun you have. Best thing to do is start out with 0. And then unfortunately, because we're attached to a bone, a lot of our coordinates don't quite line up the way we'd expect them to. For example, you would expect this to deal with height, but it's actually going across. So it's about finding how you've been completely thrown around by the socket and then adjusting to it. -90 on rotation is a good place to start. And then -180 on our pitch value is also worthwhile as well, and that's getting pretty close. More importantly is that we line up the gun with this hand here, because that hand is going to be right in front of the camera. So these are my close enough values. We've got -5 on the X for location, 2.5 on Y, and 0 on Z. We've got -90 in rotation X, 170 on the Y, and 10 on the Z rotation. And when we compile and save and look at that, it's not the worst thing in the world. Again, take your time rotating if you want. I might adjust this just a little bit more. Let's try 11. And it really does get finicky like that, where I'm changing one value and it seems to make all the difference. And that's pretty much as good as it's going to get for now. But the most important thing is that now that the weapon is attached to the arms, when I jump, the weapon tries to follow those animations. It's just like wobbling your arm around with your hand loose, how your hand's trying to respond to your arm. And you can probably hear in my voice that I'm doing that now, even though you can't see me. So we'll leave it there for now. And one very, very final thing I will do is show you where those sound effects are coming from. So if we were to go to the animations and open up one of them, let's say open up our rifle run. If we were to open that up, we can see here a timeline of this animation. I'm just going to pause that down here. And so the animation is now referring to sound effects in these locations, and you can add those locations, and we will do so at a later date, perhaps once we have some other assets to play with. But for now, we're going to leave it there and return in a later episode with more animation goodness.